So I'm going to put that there, and we're almost done. Times f, which is that whole thing, right? That big, ugly thing over there. Everyone see that? Yeah? And what's not good here?
You have to take the derivative of that, which means you have to do the same thing, but with that part.
That's right. So this is just the formula, right? We're just using the formula. We now have to take derivative of this, right? But we have a product. We have a product. So we have to do a product rule on these two. It's like its own product within the bigger product. So we're doing a product rule inside of a product rule now. Right? Because our rule says if we ever see multiplication between two things and we want to take the derivative, we have to follow that rule. So it's like a new thing. It's like a new little f here and a new little g. Then we do our little thing. All right? So we got to keep track of all our parentheses and stuff here. All right? Amanda?
Yes.
Where's Amanda? Are you following, Amanda?
Yes.
Okay. Amanda, I'm going to see if you can do this. Just what's in here, Amanda. Just this thing right here in green. Can you help me write down what I need to do for that? And I'm going to put a big pair of parentheses here so we don't confuse ourselves. I'm about to do that. Here it is. What do we got, Amanda?
So we x cubed plus 1.
That, derivative of that. So the derivative of the first one times the second one. Keep going. Plus the derivative of the g, which is the second one, which I'm just going to write down. I haven't taken the derivative yet. Just I'm going to take derivative of that, and then almost done. Times f, which is the x cubed plus 1. Boom. There it is. Everyone see that product rule that we have to do within the product rule? Now, good job. We're not done, obviously. Yamna. Yes, you okay with this? Okay, I want you to, this was just this. Can you help me just write out the rest of this? Because I'm not, like I've left stuff off there. So what do I write next? Times sine x, right? That's this piece here. Plus, do you want to go ahead and do the derivative? Yeah, so Yamna's going to do the derivative here. Everyone, cosine x times, and then just all this, right? Okay, no derivatives on these. You want to keep going or you want to move on? You want to move on? Keep going? Okay. Real important here. Everyone see this green set of parentheses? We got to keep these here as we do the derivative. So I'm going to go ahead and put a big pair of parentheses there. All right, go ahead, Yamna. 3. You're taking derivative of this, right? So 3 comes down. X to what power? No, remember that's right. 3x squared. There we go. 3x squared. Good. And then plus derivative of 1 is 0, so I don't need anything there. Everyone see that's a derivative of this right here? All right. This we're not taking derivative of. So I'm going to put it in parentheses. X squared plus x minus 4 plus, okay, I want to try and get through everyone. Stephen?
2x plus 1 times
2x plus 1. And then you said times what? X to the third plus 1, right? And we need parentheses around those. So just some language here, just so you know. If you say that you want to write 2x plus 1 in parentheses, you could, of course, say, in parentheses. But math people, we like to say the quantity 2x plus 1. Okay, and that tells everyone we're talking about something in parentheses. The quantity 2x plus 1 times the quantity x cubed plus 1. All right, and then just rewrite everything else, right? Times sine x plus cosine x, x cubed plus 1, and then x squared plus x minus 4. There it is. This is our raw derivative. Right? There's no more primes anywhere. We've taken all the derivatives we needed to. So you can see here that the product rule can be extended from 2 things to 3 things, right? But if you go from 2 to 3, you're going to wind up doing a product rule within the product rule. Now, I'm not going to torture you and do 4 things, all right? The most you'll see is 3, but theoretically, we could do 4 things multiplied, 5 things multiplied, right? There's no limit to how many things.
You would just keep chaining the product rule,
Yeah.
using product.
You just use, there would be products within products, the whole, like, it would be a mess, but you could do it, right? The rule is very powerful because it allows us to handle any number of factors now. It's ugly, yes? It's ugly. But it's way better than trying to do it with the limit, I can tell you that. If you tried the limit, there's no one in here. I wouldn't even, I mean, like, if someone gave me that as a limit and tried to, you know, say find the derivative using limit, h goes to 0, f of x plus h using that definition, I would quit. I wouldn't want to do it. All right, we good? Let's talk about the next rule, the quotient rule. So right now, we have this rule here, the product rule, that allows us to take derivative of 2 things being multiplied, and we've even seen we can now handle 3 things being multiplied, right, in 4 and 5. So this is really useful. But what about a quotient? So let me give you the rule first. And then once we get the rule, we're going to start using it. And then we want to become proficient with those rules because we need to be good at these rules to do the next rule, which is next class, which is the chain rule, which I warned you about last week, right? The chain rule is the big one. So, quotient rule. All right. So we already know that rule, how to do products. But how do you do it when you have a function on top divided by a function, right? That is a quotient, and we want to take the derivative of that. Again, wouldn't it be beautiful if all you had to do was take the derivative of the top and bottom? Wouldn't that be great? But if you look, the product rule didn't work that way, so I'm pretty sure this is not going to work that way as well, right? And it doesn't. So here it is. You ready? It is, without a proof, sorry. Let me turn this off. All right, it is the derivative of f times g of x. So far, look at that. It's the same as this, isn't it? So far. But instead of plus, we now do a minus, and then g of x g prime of x times f of x. So look, that's exactly this formula, isn't it? Exactly this formula, but with a minus between instead of a plus. That's good, right? That's good. It looks a lot like this formula. One more thing, though. One more thing. You have to take this entire thing and divide it by the g of x squared. That seems like it's coming out of nowhere, right? It's like, whoa, where did that come from? Well, I'm not proving it, so you're just going to have to believe it, that that's what it is. So you're going to basically do the product rule, right? You're basically going to do the product rule like we just did, except you're going to use a minus instead of a plus. And then when you're done, you're just going to remember that you need to take that answer and divide it by the whatever denominator, whatever this function is, you're going to divide by that function squared. Notice down here, you're not going to take a derivative. You're just going to divide by that function squared. So let's do an example, all right? Maybe I should say this in words. Yeah, let me do this in words. So if I do this in words, I call this the top function, and this is the bottom function, right? Numerator and denominator. So the quotient rule in words goes like this. We're going to take the derivative of the top times the bottom, right? Derivative of the top times the bottom minus the derivative of the bottom times the top. I know this is a lot of words to have to remember, but you'll burn it in eventually. derivative, so minus, right, minus the derivative of the bottom times the top, and then over the bottom squared. That's supposed to be a quotation, like, you'll hear me say that as we proceed, right? I'm say, okay, we got a quotient rule. We're going to do derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. All right, example. Here's an example. Let's start with y equals, let's do x squared plus 1 over x cubed plus 1. That is a quotient, right? That is a quotient. Do you all see the top and bottom functions, the f and the g? So up here, this is the f. Down here, this is the g. All right, let's go for the answer here. Y prime equals. All right, so there shouldn't be a big difference between this and what we were doing before, right? Except a minus in between. Gabriella. Hi. You go by Gabriella, right? Okay.
So I have, well, parentheses, what
Yep.
was the term you used?
You could say the quantity, but let's just go parentheses.
Okay.
Yeah.
Parentheses, x squared plus 1, and then taking the derivative of that,
Okay.
times x cubed plus 1,
Okay, in parentheses there. Minus.
cubed plus 1, taking the derivative of that, times just the top, so x squared plus 1, and then it's going to be over x cubed plus 1 in brackets squared.
Yeah, I'm going to put parentheses. You don't need brackets. The reason I use brackets is because most textbooks do, but brackets and parentheses are exactly the same thing in math. There's no distinction between the two. When you're talking about using them to separate things, there are differences. We're talking like intervals because then it's like include the endpoint or not, but in terms of like just within an expression, they're the same. Okay, thumbs up or down on Gabriella? Yes? Any objections? So is it that much of a difference from the product rule? Just the minus and then the division thing, right? As far as taking derivatives, I'm just going to do this real quick. The derivative of this is just 2x. Parenthesis, x cubed plus 1. Minus the derivative of this whole thing is 3x squared. Parenthesis, x squared plus 1. And then the whole thing over x cubed plus 1 squared. There it is. That's the raw derivative. We will have the pleasure of doing something with that later, but for now, we just want to get the mechanical part of this down. Right? I mean, think about some things you could do. You could like distribute through here, right? There's all sorts of different things, combine like terms. All right. Let me write the rule down over here. It's also, well, I'm going to talk about the formula sheet in a second. Hold on, I'm not ready for that yet. So this is f prime times g minus g prime times f all over g squared. Okay, there's our formula. I'm going to put the next problem on the board. I'm going to give you a minute just to see if you can get the raw derivative. Take a minute to see if you can write out the raw derivative of that. Raise your hand when you get it, when you're done. You can put your hand down. I just want to kind of get a mental tally. Okay. Got it? Okay. No? Got it? Got it? Yeah? Okay. Okay. We'll go another 30 seconds here. Sophia? Is that you? You ready? Sophia? You said you feel okay about it? Think so? Okay, help me write it out like, don't give me the final answer, just help me write it out with the primes first. So what would you do? Derivative of x times cosine x minus derivative of cosine x. I'm going to put that in parentheses like that. Times x. Very good. Cosine of x squared, right? Like this. Okay. Everyone good? All right. You want to keep going? All right. So now that equals, so what's this? 1 times that is just cosine, right? Okay. Minus, this is the trickiest part, I think, of the whole thing. You have minus, and then derivative of that is negative sine x. So you're going to have a double negative there, aren't you? Which will turn into a positive, but let's just keep going. Times what? Times x. And then all over. I'm going to rewrite this bottom like this, because these two things mean the same thing, don't they? Everyone good up to that point? So the last thing I'm going to do is I'm going to take this double negative, I'm going to turn it into a plus sign. And then also, I don't like this x back here, I'm going to slide it to the front. And that's going to be my final answer. There we go. All right. We're feeling good, right? Feeling good. Feeling real good. Take a moment to think about this first. Marcus? Marcus? No? Matthew? There. How's it going? Okay. So, Matthew, do you see something disturbing about this problem? What is disturbing? What's bothering you here? You have a product rule on top, don't you? Everyone see that, multiplication? But it lives within a bigger problem, which is a quotient, right? So let's do this the way that, well, how do I say this? Matthew, can I convince you to think of it this way? That this is like some function f on top and that this is some function g on the bottom. Can I convince you to look at it that way? Everyone see that? And then Matthew, can you help me just set up the quotient rule off of that information?
So it's going to be the x sine of x, parentheses.
Yep.
And then the
Derivative, right?
and the
Good.
minus the x plus 1.
Good.
Parentheses, sine x.
X sine x. Good. Almost there.
And then divided by x squared plus 1 squared.
There we go. Perfect. Everyone see that? We do have a product, okay? But first we look at the quotient. And we're going to say we're going to treat it like a quotient. And this we will put that as our f. And so all we're going to do is put it here as f and then take the derivative. So there's your derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, right? That's the formula. Now, Matthew, good job. Juan, where's Juan? Okay, there you are. Feeling all right? Yeah, okay. Juan, shit. What now, Juan?
I'm not sure if you would take the derivative or if you would treat that as, do that other question where we split it up into two. Or how we have like, what was the word? It's like a question within a question.
Okay, let me ask you a question here. We have to take derivative of this, right? What do you see right here?
X times sine x.
X times sine x. So you see a product. So you're going to have to use the product rule there, right? So everyone see that? You could even hear the way Juan said it. X times sine x. So there is a multiplication happening right there, isn't there? Which means that Juan has to apply the product rule. Now, Juan, we can either do it right here if we want on the next line, or we could even do scratch work on the side and go figure out what the derivative of that is over there and then bring the answer back. Totally up to you. What do y'all think? Would you want to do it like within the problem, or do you want to go do scratch work? You want to do scratch work? Scratch work, okay? So over here, I'm going to do some scratch work. What I'm going to do is I'm going to take the x sine x, and I'm going to go find the derivative of that as if it was its own problem. And I'm going to use this rule right here. So Juan, you want to tell me what that would be according to the product rule between those two?
X prime
X prime
times sine x
times sine x
plus
plus sine x, that derivative, prime, times x, right? And the derivative of x is 1, so this is just sine x. And the derivative of sine x is cosine x, right? But then we have an x out here. I'm going to bring it in front. X cosine x. Did I go too fast there? Is that all right, everyone? Did you all see that? Now that's just the derivative of that piece, right? So I need to take that and I need to reinsert it over here. That's going to take the place of this right here. And everything else is still here, right? So I'm going to put sine x plus x cosine x. That's my scratch work from over there. I still have x cubed plus x minus, okay. Isaiah? Okay. Isaiah, are you following okay? Yeah? So I've just done that here, minus now. Isaiah, you get this.
All right. It would be 3x squared.
3x squared. And that's it, right? Okay. And then I have times x sine x. And then over on the bottom, we're not doing anything, right, Isaiah? We're just rewriting what this is. There it is. That's your raw derivative. You're done with the derivative when you no longer see any prime marks, right? So you're probably wondering where these formulas are on your sheet, right? What is it, page 5, reference page 5. The product and the quotient rules. All right, I want us, please, if you have your formula sheets, I want you to take them out. If you don't, this is important that you go home and do this at some point. All right. Let's read this formula. Can you all see that enough? I mean, you have it in front of you as well. This right here, this d dx, is like the prime mark I have over here, right? Instead of writing prime, your formulas have d dx out front, which tells you, hey, take the derivative, right? So if you want to take the derivative of a product, let's see what their rule says. Their rule says you don't take the derivative of f, and then you take the derivative of g, and you add to that, you don't take the derivative of g, and then you do the derivative of f. That's not our formula, right? That's not the formula I showed you, right? And then when you look at quotient rule, look at what they do. They say g, take the derivative of f, minus f, take derivative of g, and then divide by the g squared. Do y'all see that if you look at the book's version of this, this right here and this right here are not the same, are they? Like on my formula, they're the same except there's a minus between them, right? That's the only difference between the two. The way the book presents it, this and this look like they're completely different formulas, don't they? Do y'all see that? Look, f here, but here it's f prime. G prime here, but it's g. And then g here, but it's f, and then f prime is g. Do you see it looks like two different formulas? So when I was a student, I learned it this way. I was like, what the hell? This is, okay, fine, I learned it that way. But as I got more comfortable with math, I realized that you could just rearrange things and they would look almost identical. And so I teach it that way because I think it's less for you to remember. If you can get the product rule down, then the quotient rule is just a minus and divide by the g squared. So what I'd like for you to offer to you is for you to scratch these out on your formula sheet and put in my version in instead. They are mathematically equivalent. Do you understand why they're the same? Look, this is multiplication, right? Can't you flip multiplication over? Right? You can flip these. If I flip these and flip this and flip this, I would get g prime times f plus f prime times g. That's what I would get if I flip those two. And then addition is commutative as well. I could flip the order of addition. If I flip the order of addition, then you're going to see the formula I just gave you. So I'm not changing anything, I'm just rewriting it a different way. And then same with over here. If you flip these over and flip those over, you get my formula. I don't know why they do it that way. It's always confused me. It seems like there's more to remember if you do it that way. But I'm showing you this because if you go to a tutor for help, they're probably going to do the product and quotient rule the way it's done in a book because that's the way they learned it. Just a fair warning to you, okay? Any questions on that? I can always tell when I grade tests who went to get help somewhere else or who learned this in high school and like learned the product and quotient rules a certain way because they will use this. And then the students that learned it in this class and stuck with that formula, I can see the difference on the test. Just the way they use the formulas. There's nothing wrong with doing it this way. There's nothing wrong at all. It's just my personal preference to do it the other way. All right. How much time? This is off an exam review. Let me zoom in a little bit. I'd like to let the rest of today's class be a group assignment. You work together. If you finish these problems, you can call it a day. What I want is for each of these problems, I give you a function, right? And I give you a point. And I want you to find the equation of the tangent line to these curves at those points. So kind of like the quiz problem, right? This is exactly like the quiz problem number 2, except your derivatives are going to be a little more challenging because we got to use some rules, right? So on the first one, do you need the product or quotient rule? No. Second one, product or quotient? No. Third one? Yes, product. This one? You have a product here and then you have a plus here, right? So you can do these separately, but do that product rule. And then this one? Quotient, right? Okay, so what I recommend you do to start is why don't you just work together or work alone. Make sure you can at least just get the derivatives of these. And then once you get the derivatives, you can go back and answer the rest of the questions, all right? Have at it. Raise your hand if you have questions. That's all we're going to do for the rest of the day. And then, of course, do your homework. Because when we come back on Thursday, when we come back, we're going to start the chain rule. And if you can't do the product and quotient, if you're not comfortable with it, the chain rule is going to be that much harder for you. All right, have at it. This is just exercise for you, all right? I'm going to stop recording and